We usually take a really holistic look at the organization. We look at all of their policies, procedures, how their people are trained, their onboarding processes, and everything. But today I'd like to focus on just a few items that are particularly relevant to medical device security. And we're going to walk through these. Won't be able to go into some of them in depth, but I want you to understand that these are essential parts of a security program to help keep your medical devices secure. So we'll go ahead and start off with inventory. The thing about inventory is that if you don't know what you have, you can't protect it. You need to know what you have so that you know any vulnerabilities that are associated with those devices, and you need to be able to track those and keep an account for them. The most successful organizations that I've seen do so by dividing and conquering, and they need to do the same. Where basically you designate in any functional area or department, clinical or administrative, you designate business owners or you designate some type of custodian for the devices. The key point here is that if you haven't already assigned ownership for the devices in use by the organization, that really needs to happen in the first step as part of the security program. So the next step is risk assessment. Now, granted, we could talk about risk assessment methodology all day. We just don't have time to do that, but I want you to understand 3 key points about risk assessment. The first is knowing what you have, and not only what you have, but how critical is it? You know, what is the impact? As John pointed out, the impact might be, patient well-being. The impact may be a privacy breach. But you need to understand that all of the equipment that you use, all of the systems that you use, each have different attributes, and you need to understand how critical they are and the type of data they have. John just mentioned a lot of threats. The threats are real, but you need to understand how the threats could impact your assets, and then you need to know what types of controls you currently have in place in order to reduce the risk of those threats. The end game is that you want to know the residual risk. Why do we do that? Well, part of the reason we do that is so that we know where to apply limited resources. So I won't go into the risk assessment methodology, but I would like to point out a couple of resources. Obviously, risk assessment is not the same as risk management, but as you, of course, know, HITRUST provides a risk management framework. And so once you've done your initial assessment and you record that information in your CSF, then you can go about implementing the controls that are going to reduce risk and then monitor that over time. There is another resource that I found very interesting, and I don't know if anyone else here has used it, but it's the Medical Device Risk Assessment Platform. Well, how this differs from a typical risk assessment platform is that it is a community effort, and the individual service delivery organizations actually upload inventories of their devices, and then they can share information about the vulnerabilities of those devices and risk mitigation strategies. So again, we don't have time to get into it, but I certainly encourage you to take a look at that if you're in a service delivery organization. And then finally, we have the granddaddy of guidance, the NIST guide for conducting risk assessments. So just understand that risk assessments are an essential part, although it may not be the most actionable part. As a penetration tester, I essentially get paid to break into networks, break into systems, and exploit them to get sensitive data. This next section, device security hardening, is usually the key to how successful I am on a penetration test. How well the organization does these things will determine on whether I own the entire network or whether I just find a few anomalies. So we'll go ahead and jump into that. Probably don't have to say it, manufacturers typically release products with, and for a reason, they'll release products with default credentials and passwords so that you can set them up initially. And they also will sometimes include default settings and services on those devices. This is a term I like to use as a penetration tester. Those things are low-hanging fruit. So as an adversary, I don't even have to work very hard. I can go in, do a quick search of the network for management interfaces, find the default passwords, and log right in. So part of the system hardening is ensuring these things are changed. It's also ensuring that the ports and services that are on the device that may or may not be necessary for daily operations are disabled if they're not needed. So just to give you one example, most devices have a file transfer protocol port. So it's basically how the port is how it communicates across the network. FTP is there for a reason, so that you can copy, update software updates and firmware updates to the device. But unfortunately, that port, that service can also be used for copying over malicious payloads, which can then be served to other devices on the network. So if you actually don't need the FTP for daily operations, part of your system, your device hygiene would be turning those services off. Another example of a service that may or may not be needed is management interfaces. Now, management interfaces may be web-based, they may be logins, they could be HTTP, which is unencrypted, or they may actually be secure. But the point is those management interfaces may or may not be needed. And again, as part of the hygiene, there should be some type of checklist in your organization where you determine what services need to be turned on or off, particularly if the service is an unencrypted protocol. So I don't have a laser pointer here, but basically the little block in the middle is to represent a command line interface, type interface through Telnet. Telnet's a legacy protocol, it's unencrypted. Unfortunately, everything you type into a Telnet session is sent in clear text across the network. And as you can see in the example on the right, it's easy to use a tool to sniff that right out of the network and be able to see passwords and sensitive information. So another service to consider turning off. We talked about operating system updates. Security flaws are found all the time, just like Microsoft just discovered a flaw that had not previously been known. The first step is, of course, is knowing that all of the security patches have been applied prior to a system being deployed or a device being deployed, but also then to maintain an ongoing patch management process. Firewalls, not every device is equipped with a firewall, but many devices do. They're based on Windows operating systems or Linux operating systems. So those ports and services I was talking about earlier, if you can enable a firewall on the device, the ports and services don't go away, but they just become invisible to the network. So certainly, unless there's a business reason not to have the firewall on, we encourage you to turn the firewall on. And then finally, this may not seem like a preventative measure, but part of the hardening checklist is typically making sure event logging is enabled on devices. Not only will event logging provide you with a record of what happened on the device, should you ever need to go back and do post-investigation or forensics, but it can also be used in a more proactive manner. So, for example, if you use some type of tool to aggregate the log data, you may be able to use something like a security information event management system. You know, it's become almost a dirty word in some parts of the industry because they take time to implement and they take time to manage. But the thing is about those systems is that they can listen to multiple logs, identify events based on predefined rules, and alert the staff on the highest priority events. Now, you can do that either through active analysis, but who can afford the staff to do that? So you typically end up using automated tools. Again, as part of a long-term strategy, the magnitude of the data that's generated by devices on the network is way too great for any human to actually keep up with. And so the trend now is to go to automated systems that actually do the analysis of the events, determine that there's an anomaly, things like login attempts, things like changes to systems or software files. Those are types of things that an administrator on the network would want to know. And there are plenty of tools out there. So we'll talk a little bit more about the monitoring part shortly. I'll go ahead and jump over to the network side. Well, we're talking about devices, so why does the network matter? Well, no device sits in a vacuum. Any device connected to the network, wired or wirelessly, it communicates across the network, it sends data across the network, it's constantly in communication on the subnet that it's on. This is where network segmentation comes in, basically ensuring that your network is broken into smaller pieces with some type of access control mechanism between. As in this illustration, it's a firewall, but you can also do some degree of segmentation using routers and switches to create parts of the network where information that's broadcast on the segment does not broadcast across into other security zones. So this is one way to limit the impact should compromise occur. So for example, in this illustration, if a workstation in the administrative zone was compromised, it would not be able to get immediate access to devices in the clinical zone, nor would it be able to listen to information that's being broadcast in that zone. So segmentation is important. So real quickly, we've already talked a little bit about encryption. It's not a good idea to send unencrypted data over the network, but that can also happen at the application level. So if you have a workstation where you have an application that's monitoring one or more devices, it's best if you have the opportunity to encrypt that to go ahead and do so. That way that information cannot be intercepted or cannot be easily modified. The same is true if you're communicating from outside of the network. This is pretty much common sense to most of us who've been in the industry a while, but if you have remote users that need to access internal resources, obviously you want to ensure that the data that's traversing the internet is encrypted, because anyone in between on any piece of infrastructure in between could eavesdrop on that and collect the data. Physical security, not much to say except that they're in a clinical environment or in a care environment, access to facilities needs to be fairly open. And so sometimes it takes a little bit of thinking and a little bit of strategy to determine how are you going to control access in and out of non-public or restricted areas of the facility. And then in addition to that, you have equipment and devices that may or may not be in use all the time. And just like the example I heard earlier, you get the device out of the drawer, you turn it on, and you find out it works or doesn't work. Well, those devices need to be locked up somewhere. They need to be secured in a manner so that nobody can modify or tamper with them. So just a little bit more about monitoring. There's really two types of monitoring, and the one we described already is primarily passive monitoring, where you're collecting logs, you're collecting video surveillance. You basically want to have that information preserved so that you can go back and look at it later. But then there's also the active monitoring, where you get live alerts. The key point here is even if you install a system that may seem like a turnkey system, you're going to have to designate somebody to be responsible for responding to those events, to be able to both contain, mitigate, and recover. Containment, keeping it from spreading, mitigating, making sure that it can't infect other systems through some type of patch or modification to the system, and then eventually recovery back to a normal operating system. So once you determine who's going to do it, you determine some procedures to do it, that essentially becomes your incident response plan. And so those elements are essentially the ones that are involved in device security. And I'll go ahead and pass it on to Blake now, and he'll talk a little bit more about the industry. Next slide.